All right, in problem number 3, we've got a row of 1-inch squares that are placed side by side with their bases on a line down here. And then this middle one is lifted up and turned 45 degrees and then centered and lowered into its original location so that it touches both adjoining squares. And the question is, how many inches is point B up here from the line on which the bases of the original squares were placed? Alright, well, I'm going to scroll down here and make this a little bigger so that you can see what we're doing here. Oops, I guess I have to select it. Alright, so I'm just going to make this a little bigger so that we can work with it a little better. And so let's look at what we're dealing with. We know these squares are all 1 inch on the side, right? So this is 1 inch. Probably make it look like a 1 and 1 inch. All right. And so the same thing over here. This is 1 inch over here, 1 inch along this edge. All the edges of the squares are 1 inch. So what does that mean for the diagonal? Alright, so if I were to draw a diagonal of this square here, because I know that's part of the height, right? Not drawing a very straight line, but alright, so pretend that's a straight line, a diagonal of this square. Alright, and so how long is that? Okay, so we have a 90-degree angle here, and the sides are all 1 inch, right? 1 inch on each side. So we can just use the Pythagorean theorem, which would be 1 squared plus 1 squared is equal to 2, and that's equal to c squared, which is the diagonal, right? It's the hypotenuse of this half square. So the diagonal is equal to the square root of 2. Alright, so we know now that this is the square root of 2. And that's actually a good, for 45, 90 triangles, this ratio of the sides, 1, 1, square root of 2, always holds. Even if this is 2, if this side were 2 or 3 or 16 or 849, this would be that the hypotenuse is always the square root of 2 times that, okay? So, oftentimes, it's just a good idea to remember that if you have a 45, 90 triangle, then the ratio of the sides is 1, 1, square root of 2, okay? And then you just scale it up or down based on what the actual dimensions are of the thing you're working with, okay? But in this case, we have 1, 1, square root of 2, okay? Alright, so now we know the diagonal of B is, of this shaded block, is square root of 2, but we still need to know this distance here, right? And if we knew that distance, we could add it to the square root of 2, and we'd know how far B was above the line. So let's take a look, though, at what we're doing here. We're turning this block by 45 degrees, and then we're lowering it straight down, and it says that it's centered. It's centered and lowered. Okay, so this diagonal line is centered right above the place where it was originally put. So if I were to draw, here's where our original square was. So I know that this is 1/2 and this is 1/2. All right, so these distances cross here. From the center line to the edges of these adjacent blocks is 1/2. So I could actually write 1/2 in here and 1/2 in here. Okay? And because this is a 45, 90 triangle, you can see, actually let me pick up another color so I can draw a little more. You can see a 45, 90 triangle right in here, right? And this ratio still holds, right? So only this time we just need to scale it down by 1/2. So this distance here is also 1/2 right there. All right? But, okay, so let's draw this in a little bit here. Draw a little more in. So you can see that this is a half, and we know that this is 1, so this, alright, so this is a half over here, and this is a half. So that means this has to be a half, okay? Because it's a 45-90, so this is 45 degrees, because we're told that it's rotated by 45 degrees. So we know this angle is 45 degrees. So we have just a bunch of 45, 45, 90 triangles. And the legs, the length of the legs are going to be the same. So if, if this leg here is a half, then this leg here is a half, alright? And if that's a half, alright, then we can make another one here, then that's a half, and because this whole thing was 1, this is a half, and since this is a square down here, then this is a half again, right? Okay, so now we can figure out how far B is above the line. We've got a square root of 2 right here. So this distance right here, this diagonal coming down, is the square root of 2, and then this distance is a half. So the distance from B to the line is the square root of 2 plus 1/2. It's not a very good color to write in. Okay, let me write it again. The square root of 2 plus 1/2. Alright? So, and what's the units? Well, we're given everything is in inches, so this is 1 inch, 1 inch, so this is actually inches. Okay, so if you want a decimal form of this number, square root of 2 is 1.41, so half is 0.5, so that gives you 1.91, approximately 1.91 inches. Alright, so there you go, there's your answer.